All right. Hi, everyone. So today I'll be talking about modeling, specifically building a 3D geometry in SimVascular using the segmentations that you may already have. So first, what is a model? Essentially, you can kind of see the finished product here in this bottom right screen. What it's essentially doing is it's taking your segmentations, lofting each one, and then unioning each each of the segmentation groups. So in this example, it's the aorta and right iliac that are being unioned together into to create one solid object, as opposed to the two solid objects that these were previously. And so in order to do this, it's a very simple process actually. You would go to models, right click, create model, very similar to what you've done before. Model type we'll leave as polydata for right now. That is the kind of the default. And then you put your name in, name for the model. You double click on it in the tree, which will bring up a side menu here. And you want to click on the button that says create model. And so here it brings up a kind of a small window that will list all of the segmentation groups that you have already built in whatever order. And then what you want to do is you want to select now the segmentation groups that you want to union together into a single model object. And so for this example, we're going to be unioning the aorta and iliac. So in this example, there are only two, so it's easy to just click these two checkboxes. But some of you may be building a little bit more extensive models, so it may make sense to click, and if you hold down shift, you can kind of click multiple. It's also like if you hold control, you can click multiple. If you hold shift, it'll grab the entire. It'll select all of them in between the clicks. And so if I wanted to select these two, you can right click and say use selected here. All right, and then so with these, we'll just use these two. And all right, and so the model creation, I mean, so for these simple models can be relatively fast, but for some of the larger models, it can take several minutes to make. And so what the first thing you should check, there's a few things that you should check right after you make a model. One is that you want to make sure that if you look at the now face list, so this represents all of the different faces that are in your model. And actually, let me go ahead and take off these. So this is actually, by default what shows up. And let me make this side. So for now, the image planes are not going to be as exciting as the 3D view here. And so the first thing you want to check is to make sure that the number of caps that you have, so in this case 3, it is what you expect. And from our knowledge of the geometry, we do expect 3 caps, which is what is in the model. So we have 2 caps and so every time you select a cap, it'll highlight the face in the 3D viewer. And so we have the 2 caps that are from the aorta segmentation group, and then the 1 cap that's at the outlet of the right iliac. Now, if you had done this, and so one way that this could go wrong is if you accidentally didn't if you didn't start your vessel completely inside the other vessel, which may have been explained in the segmentation video. And so if that doesn't happen, you'll see that there's an extra face generated here. So there's an extra face generated here that you will now you have four caps instead of the 3. And so it's this cap here that is kind of trying to take in this ledge, which is incorrect. And so just that's what will happen if you don't do it properly. Okay. So going back to here, the next step is that you also another way that this could fail is that if you had segmentations that were self-intersecting, which was also explained in probably the segmentation video. And so if that happens, you'll see a kind of a dialog box appear saying that something might be messed up, and or it might error out completely by showing it in the terminal here. It might just say self-intersection found, and it might just stop the model making process. Okay, and so once you get a good solid model and you know that the caps are well defined, then some other interesting visualization tricks that you can use is one, if you want to view right now you're just viewing the model as like kind of a blended face. Sometimes it's useful to see the edges. And so now these blue lines represent each of the edges, the kind of each finite kind of element in this model. What's important to see here actually is the first thing to note is that at the caps, by default, these caps will look very odd. And so you can kind of see that what's actually happening on these caps is it's just connecting each, kind of opposite edge of this cap together. And this kind of geometry, or this kind of cap geometry, is very poor when you're doing a simulation. And so what you want to do, the first thing you want to do when you make any model through this polydata thing is you want to remesh the caps. And so to do that, you had to select all the caps. And so you would do that by clicking one of the caps and then holding shift and then clicking the rest of the caps. And now that once we selected those caps, we can go over to face ops, this tab here. So there's global, local, and face ops, which is what you want to be. And you want to go under remesh. And so if you go under remesh, so here there's extract and then remesh. You want to, you can click an estimated size, or you can enter in your own value, and you want to hit this remesh button. I don't necessarily want to press it right now because that can take some time. What it will look like is something like this. Something like this. This is a cap that has been remeshed, and so it looks a lot better. You have these interior nodes. I would suggest maybe remeshing this a little bit finer potentially, and so this is just an initial pass. But you might want to maybe refine this cap to have more interior nodes, which will make the simulation a little bit more precise. Okay. Some other visualization techniques, or tricks rather. And so the edges are sometimes annoying to look at, so you can turn it on and off. If you ever want to know where a specific face in the list resides in the 3D viewer, you can hover over the face that you want to interrogate and press S, which will highlight it in the list. And so you can do that with any face. It's especially useful for the caps when you don't know sometimes which cap is where in the 3D geometry. And then so by hovering over this, you can kind of see all of the shortcuts for any interactive feature that you can do. You can do faces as well as selecting cells and things like that. Okay, and then the other options, of course, is you can change the color. You can change color. You can change the opacity as well, if you wanted to turn it on and off, or if you wanted to just change the opacity of the model so that it becomes more transparent. Okay. So the next bit here is you want to, so a lot of simulations may require knowledge of the area of each cap. So these caps represent the inlet and outlet of the models, the inlet being this cap aorta here, and the outlets being the other two. One way to get that information very easily, the cap area, is to right-click on the model of interest and then go to Export Cap Info. And if you click that, it'll bring up a dialog box to save the caps as a file. And so if you do that, which I've already done here, and you open it up, it will show you in an Excel kind of file uh, each cap and then its own area. The units of this area are going to be the units that are the same as the geometry. So in this case, I believe it is centimeters. So those are going to be in centimeters then. Okay. The next bit here, so there are a few other things, face ops or rather global operations as well as local operations. These two tabs really, what the difference is, if you want to do a global remeshing or a global or apply one of these kind of global filters to the entire model, that can be found here. If you only want to do it to a certain region, for example, if you select the sphere, you can move the sphere around so that you're only applying these various operations to inside that sphere. I don't necessarily want to for the sake of time, I'm not going to go through each of the differences between each of these kind of algorithms. If you want to know more, I would suggest going to the SimVascular documentation, which explains in detail each of these kind of algorithms. Another thing you can do is you can trim. So by trimming, so before, let's turn off the sphere. So for trimming, you can you can show the plane, and it will bring up this plane now that you can move around, and then truncate the geometry at any point, cutting above or below, and then you can even follow a path if that is what you want, and then you can also truncate by box as well. Okay, and the last thing I want to go through is the center lines. So you can extract center lines via this button, or you can right click and extract paths from here. For the sake of time, I've already done that in this model here. Oh, before I do that, so yeah, so sometimes you have to turn off manually the spheres and stuff. Okay, so if I go back to here, I've already generated a center line for this model, and I've changed the opacity of the model to visualize it. And so you can kind of see it a little bit better with this one. And so that is going to be, it's going to be a center line that you can go ahead and right click and save as its own object. And that this center lines are very useful for various applications, things like getting quantities of interest along the center line, or building a 1D model, for example, from your 3D geometry. So those are all very important. Okay, and that about concludes all of the steps, the things you can do with the polydata model. The next thing I wanted to show was if you creating a different type of model. So in this model type now, I'm going to select Parasolid, and it's going to be a Parasolid model. The difference between the Parasolid and the polydata, they are, I mean, there are a lot of details with that, but in general, the Parasolid uses the segmentation contours and kind of, it has some ordering knowledge, so it uses it. They basically have two different methods to create the model and union the objects together. In my experience, Parasolid is definitely a little bit more robust and user friendly, where it would tell you exactly what errors are occurring, but it is going to be you have to pay for the license as well, but you do have to pay for the license. And so for the Parasolid model, it's very similar. You create model in that way. You go to here to this button, you would select the models or the segmentation groups that you want to do, click OK. Same thing, it will create a Parasolid model now. It's very similar. One extra feature from a Parasolid model that you can do is if you go over to this blend tab, or let me click over here. If you go over to this blend tab, one feature is that you can actually use, if you noticed at the junction between these two vessels, it's somewhat, it's very coarse, or it's kind of very fine. Like there's a kind of a straight line here, which is not necessarily physiologically representative. So what you can do is actually blend those two faces together by selecting this in the blend tab here, right-clicking, setting radius. This is a radius that you would have to uh, kind of troubleshoot, but more or less, it should just look more representative to the image. So in this case, I'm going to use a 0.1. Say OK. And then if you click this button, blend face, what that will do is that it will now create a new face that is going to be kind of have this smoother interface between these two segmentation groups, which may look more physiologically representative when you look at it from the the uh, the 2D viewers and things like that. Or yeah, so this kind of yellow line here is how would that look. Okay, and with that, I think that kind of concludes everything for the modeling. Thanks. I guess I have to